Supernova-style science news with Julie 7 Sage.
Black holes are seen as gigantic objects that eat and suck up anything that gets near them. But in reality, it's kinda something else. Imagine a fabric that is stretched out. This is space and time. Then place a mass in the center of that fabric. Say that this mass is a star. The star will slightly bend the fabric. If you put any other smaller masses around it, like planets, they also bend the fabric a little bit, but they start to move towards the bigger mass. But if you now replace the star with a more massive, more condensed mass, it now stretches the fabric into a very deep hole, which then creates a funnel-like effect. This is the easiest way to think of a black hole. So if you replace our sun with a black hole of the same mass, the Earth's orbit would not change. We would still be gradually moving towards the black hole where the sun was. A black hole has so much gravity because of its mass that things get ripped apart when they get near it. The material that's left forms an accretion disk. The accretion disk is made of dust and gas. It's like Saturn's rings. As objects in the disk get closer and closer to the black hole, the objects cause friction. Then this friction causes extreme temperatures. The pressure of this immense radiation can push away hot gas, which scientists call winds, what is similar to the solar winds from our sun, just much, much more intense. NuSTAR from JPL and the XMM-Newton from the ESA just found that the temperature of IRAS 13224-3809 is rapidly changing. This variability can tell scientists how much energy these winds carry and give them more detail on how they're made. They used X-rays because when the X-rays from the black hole goes through the wind absorbs some of the radiation. Then once researchers detect the X-rays, they can tell what the winds are made of by the absorption lines in the X-ray spectrum that they receive, because certain elements absorb certain wavelengths of light. When these researchers detected it, they noticed changes in the X-ray spectrum almost every hour. Their hypothesis is that these X-rays are heating up the winds, and then the winds cool off after a while, thus the change in the absorption lines. Then that process repeats. If you would like to read more, go to the links below and show your supernova style.